4 kilometers beneath the ice of Antarctica, in complete darkness, under pressure equivalent to hundreds of atmospheres, there is liquid water, not frozen, not a trickle, an entire lake, roughly the size of Lake Ontario, sealed off from sunlight, from open air, and from every living thing on the surface of the planet for somewhere between 15 and 25 million years. No animal has swum in it, no breeze has ever touched its surface. And in 2012, a team of scientists decided the only responsible thing to do with a perfectly preserved, multi-million-year-old sealed environment was to drill a hole straight down into the middle of it. So how do you touch something that has been completely untouched for longer than humans have existed as a species, without destroying the one thing that makes it worth studying in the first place? To understand why this lake sat undiscovered for so long, you have to understand what's actually sitting on top of it. Antarctica's ice sheet in this region is nearly 4 kilometers thick, built up over millions of years of accumulated snowfall, compressing into solid ice under its own weight. For most of human history, nobody had any reason to suspect there was liquid water hiding beneath ice that thick, in a place that cold. Ice this deep should, by every basic intuition, mean solid ice all the way down to solid bedrock. Antarctica is, after all, the coldest place on Earth. Vostok Station itself, the remote outpost that eventually gave the lake its name, was established by Soviet researchers back in 1957, chosen specifically because of its extreme, almost otherworldly isolation deep in the Antarctic interior, hundreds of kilometers from the nearest coastline and any other permanent research base. For decades, scientists stationed there had no idea an entire lake was sitting beneath their boots. Their original mission was studying something else entirely, drilling long, continuous ice cores straight down into the ice sheet, layer by layer, to reconstruct a detailed climate record stretching back hundreds of thousands of years, since each annual layer of compressed snow traps a tiny sample of the atmosphere from the exact year it fell. That ice core drilling program eventually produced one of the most important climate records in modern science, reconstructing atmospheric conditions across roughly 420,000 years of Earth's history. And it was this same decades-long drilling effort, originally aimed at climate research with no connection to any lake at all, that unexpectedly positioned Soviet and later Russian engineers as the only team on the planet already equipped with the specialized deep ice drilling expertise needed once Lake Vostok's existence was finally confirmed. The first hints that something didn't add up came not from drilling, but from the sky. In the 1990s, satellite radar surveys of the Antarctic ice sheet picked up something unusual over one specific region, an area of ice roughly 250 kilometers long and 50 kilometers wide that was almost perfectly flat and smooth, unlike the jagged, uneven ice surface surrounding it on all sides. Glaciologists studying the data recognized what this flatness likely meant. Ice sitting directly on solid rock tends to show the bumps and irregularities of the terrain underneath it. Ice sitting on top of liquid water, however, floats and settles into a smooth, level surface, the same way a frozen pond looks flat and even while the water underneath it stays exactly where gravity puts it. This single observation was the first real evidence that an enormous lake might be sitting, completely hidden beneath nearly 4 kilometers of solid ice. Follow-up surveys using ice-penetrating radar, technology capable of sending radio waves down through solid ice and reading the reflections that bounce back from different layers and materials, confirmed what the satellite data suggested. Beneath the ice sat a genuine body of liquid water, later named Lake Vostok, after the nearby Russian research station. At an estimated 250 kilometers long, up to 50 kilometers wide, and over 500 meters deep in places, Lake Vostok turned out to be one of the largest lakes on the entire planet, and it had been sitting there completely unknown to anyone for the entire span of recorded human history. Confirming the lake existed immediately created the central defining question of the entire project. If ice this deep is normally frozen solid, why was there liquid water down here at all? The answer turns out to involve two forces working together in a way that seems almost contradictory at first. The ice sheet above acts as an enormous insulating blanket, trapping a small but steady amount of geothermal heat rising up from the Earth's crust below. heat that would otherwise simply escape into the atmosphere. At the same time, nearly 4 kilometers of ice pressing straight down creates enormous pressure on whatever sits beneath it, and under high enough pressure, water's freezing point actually drops below 0 degrees Celsius. Combine trapped geothermal warmth with pressure-lowered freezing point, and you get exactly the conditions needed to keep a lake liquid, even sitting directly beneath one of the coldest places on the surface of the Earth. Once scientists confirmed Lake Vostok's existence, a new and far more difficult problem took over the entire project. How do you actually get down there to study it without ruining the very thing you're trying to study? This is where the mission shifted from a discovery story into one of the most carefully managed engineering and ethical challenges in the history of polar science. Lake Vostok had been completely sealed off from the atmosphere, from surface microbes, and from any contact with the outside world for potentially millions of years. If researchers simply drilled straight down using standard techniques, using drilling fluids and equipment that had touched the open air and been exposed to modern bacteria, they risked flooding an ancient, untouched ecosystem with contamination the moment the drill broke through. A body of water this old represented an almost unrepeatable scientific opportunity, a genuine time capsule of what life, if any existed at all, looked like before human civilization existed in any form. Contaminating it carelessly on the very first attempt could permanently corrupt any future research on the lake, potentially forever. Russian scientists who had been drilling at the Vostok station since the Soviet era, originally for unrelated ice core climate research, spent years developing and refining specialized drilling techniques specifically to solve this problem. Standard drilling fluid was replaced with a specially formulated combination of kerosene and freon, chosen because it wouldn't freeze at extreme depth and cold. But engineers still worried about it potentially seeping into the pristine lake water below. As the drill approached the final layer separating the borehole from the lake surface, estimated at just under 4,000 meters deep, engineers deliberately slowed the entire operation to a crawl, monitoring pressure readings constantly because the lake itself, sealed under nearly 4 kilometers of ice, sits under such enormous pressure that the moment a drill actually breaches through into the water, that pressure differential would force lake water to rush upward into the borehole on its own without needing to be pumped. This detail became the actual solution to the contamination problem, and it's a genuinely elegant piece of engineering logic. Rather than drilling all the way through and physically inserting instruments directly into the lake, contaminating it with borehole fluid on contact, the team calculated the exact depth where the ice above the lake grew thin enough that the pressurized water below would push upward into the hole on its own, then intentionally stopped drilling just short of full penetration and allowed natural upward pressure to do the actual breaching for them. When the final connection happened in February 2012, after this final approach had been slowed to inches at a time, lake water surged up into the lowest section of the borehole and immediately began refreezing in place against the frigid air and ice walls above, effectively sealing itself back off from the outside world within hours before any borehole fluid ever had a meaningful opportunity to contaminate the main body of the lake itself. Researchers later drilled back down to retrieve a core sample of this newly refrozen ice, now called accretion ice, essentially a frozen snapshot of the exact lake water that had risen up and refrozen at the moment of contact, giving scientists their first ever physical sample connected to the ancient lake without ever directly disturbing its main body. Lake Vostok was never the only subglacial lake scientists were racing to study. Antarctica's ice sheet sits on top of hundreds of similar hidden lakes, most far, smaller, and in the years surrounding the Russian breakthrough, both British and American research teams pursued their own separate subglacial drilling projects at different Antarctic sites, Lake Ellsworth for the British team and subglacial Lake Whillans for the American one, each developing their own contamination control strategies independently. The British attempt at Lake Ellsworth in 2012 was ultimately abandoned mid-drilling after a critical piece of equipment failed in the extreme cold. A costly reminder of just how unforgiving this kind of engineering is, even for well-funded, carefully planned expeditions. The American team at Lake Willans, drilling into a shallower, more accessible subglacial lake, successfully retrieved water and sediment samples in 2013 using a hot water drilling method specifically designed to avoid the kind of chemical drilling fluid contamination concerns that dogged the Russian approach at Vostok. Comparing these three parallel efforts side by side highlights just how many genuinely different, competing solutions serious scientists proposed for solving the exact same underlying problem, and how differently success ended up looking across each project. To put the scale of this entire undertaking in a number you can actually hold on to, the full drilling project took over 2 decades from the first confirmed detection of the lake to the moment of breakthrough, conducted at a remote research station where winter temperatures regularly drop below -60 degrees Celsius, cold enough that exposed skin can experience frostbite within minutes, at an elevation over 3,400 meters above sea level, where the air itself contains meaningfully less oxygen than at sea level, adding physical strain to already grueling working conditions. Vostok Station has recorded some of the coldest natural air temperatures ever measured anywhere on the surface of planet Earth, including a reading of nearly -89 degrees Celsius, still recognized as the lowest natural surface temperature ever directly recorded on the planet. During the darkest months of the Antarctic winter, the station is completely cut off from resupply flights and outside contact, since aircraft simply cannot safely land or take off in temperatures that extreme. Any researcher stationed there during that stretch of the year is, for all practical purposes, as isolated as it's possible to be, while still standing on the surface of the Earth, further from rescue or medical evacuation than astronauts aboard the International Space Station, who can typically return to Earth within hours in a genuine emergency. Every member of the small winter crew keeping the station running, monitoring equipment, maintaining the drilling apparatus in between active field seasons, understood that a serious injury or equipment failure during those isolated winter months would need to be managed entirely with whatever people and resources were already on site, with no realistic possibility of outside help arriving in time to matter. This is also where the story requires an honest pause, because the mission wasn't universally praised as a clean scientific triumph. A number of international polar scientists and environmental researchers raised genuine, serious concerns throughout the project about contamination risk, arguing that even carefully managed drilling fluid carried real risk of introducing surface microbes into an environment that had potentially remained completely biologically isolated for millions of years, and that a failed or imperfect seal could compromise one of the only truly pristine ancient environments left anywhere on the planet, essentially by accident, on the very first attempt to study it. Some critics argued the Russian team moved forward with the final breakthrough before every possible contamination safeguard had been fully, independently verified by the broader international scientific community. This tension between the immense scientific value of studying an untouched, multi-million-year-old ecosystem and the very real risk of permanently damaging it in the process of studying it was never fully resolved to everyone's satisfaction, and it remains a genuinely debated point among polar researchers today. What did they actually find down there? Early analysis of the accretion ice samples produced results that were, honestly, more ambiguous than a triumphant discovery headline might suggest. Researchers detected traces of genetic material consistent with certain forms of bacteria, but separating a genuine, confirmed sign of ancient microbial life native to the lake from contamination introduced by drilling equipment or from Vostok Station's own surface environment proved to be an extremely difficult and still not fully settled scientific problem. Subsequent, more careful expeditions have continued sampling accretion ice with progressively refined contamination controls, and the search for confirmed, unambiguous signs of life native to Lake Vostok itself remains an active, ongoing area of research rather than a case that's already closed. beyond Antarctica itself. This entire line of research carries a significance that reaches well past our own planet. Several moons in the outer solar system, most notably Jupiter's moon Europa and Saturn's moon Enceladus, are believed by planetary scientists to harbor liquid water oceans sealed beneath thick shells of ice, kept liquid by a broadly similar combination of internal heat and pressure to what keeps Lake Vostok from freezing solid. If life could theoretically survive, isolated and sealed away from sunlight, beneath kilometers of Antarctic ice on Earth, that possibility directly informs how realistic scientists consider the odds of life existing beneath the ice shells of these distant moons. Every contamination control technique refined at Vostok, every lesson learned about how to sample a sealed environment without destroying its scientific value, doubles as a rehearsal for a future spacecraft mission that might someday attempt exactly the same kind of careful, cautious breach on a world millions of kilometers from Earth. Picture standing at Vostok Station in the middle of an Antarctic winter, the sky pitch black in the middle of the day, wind chill cold enough to injure exposed skin within minutes, standing directly above a lake the size of a small country that no human eye has ever seen and no human hand has ever directly touched, sealed by nearly 4 kilometers of ice that took millions of years to form. Beneath your boots, in complete and total darkness, water has been sitting essentially undisturbed since long before modern humans existed as a species, kept liquid this entire time by a fragile, almost accidental balance between geothermal heat rising from below and crushing pressure pressing down from above. Somewhere far above you, in the thin freezing air, the same kind of ice-penetrating radar that first revealed the lake's existence back in the 1990s continues quietly mapping other hidden pockets of water scientists suspect are still waiting to be found across the rest of the continent. Lake Vostok is still down there right now, sealed beneath the ice exactly where it's always been, holding on to whatever secrets it contains just a little longer, while scientists keep refining the tools and the caution required to ask it more questions without ever fully knowing, until they try, whether they've asked carefully enough. Millions of years before the first human being ever looked up at the night sky, this water was already exactly where it is today, waiting in complete darkness for a species that didn't exist yet to finally build the tools careful enough to come looking.